the discriminant is a portion of the quadratic formula that is underneath of the square root symbol. So it is whatever value you get when you simplify b squared minus 4ac. And what happens is it actually tells you how many solutions you're going to have or what type of solution you'll have. So if you have a discriminant that is a positive value, so it's a number greater than 0, that's going to mean that you'll have two real solutions. So if I were to do like a rough sketch of a parabola, right, this parabola would either come up from the bottom and cross twice like this, or if it's a downward parabola, it might cross twice right here. And that discriminant is anticipating how many times it's crossing the x-axis. Not exactly where, mind you. You have to finish the quadratic formula to do that. But it will tell you how many solutions to expect. Now, if your discriminant is equal to 0, then you're going to have one real solution. So what that means, so what that means is if I were to draw a graph of a parabola, that parabola is going to come down, it's going to touch at just one point, the vertex, and then come back up. Or it could be one that approaches from the bottom, touches, and then turns back away. But it's only touching in exactly one place. And then our last example is what if that discriminant comes out negative? So we have a discriminant that is less than 0. This means that there are 0 real solutions, but there will be 2 imaginary solutions. And so what that means is that this parabola never crosses the x-axis. Okay, it could reach its maximum and then fall before ever crossing, or reach its minimum and rise again before ever crossing. Right? And we don't have to do the entire quadratic formula to figure these out, the number of solutions. You just, again, have to use the discriminant portion. So let's go ahead and let's do some examples. So this first example is designed to have 2 solutions. So what I'm going to do is I'm going to identify our a, b, and c values. So here our a is a negative 1, because that's what's in front of the x squared. Our b is a negative 8, and our c is a 2. So then I take my format, so I have b squared minus 4 times a times c, and I plug those in. Now it's important that when you guys are substituting into your equation that you're using parentheses, because, for example, negative 8 squared is 64, but negative 8 squared is negative 64. So if you don't use parentheses, you're going to lose signs and then you won't get to the right answer. So make sure you're following your parenthesis rules. So here, negative 8 squared is negative 8 times negative 8. That is 64. And then here, negative 4 times negative 1 is a positive 4, times 2 is an 8, and then 64 plus 8 is 72. So our discriminant for this problem is a positive value. That's telling us that there's going to be 2 real solutions. It'll cross the x-axis twice. Now if I want to figure out what those solutions are, then I kick myself back to this quadratic formula and I finish simplifying it. So we can do that, right? So I have x equals, we have negative b in the formula, so negative 8 plus or minus the square root of this discriminant, so the square root is 72, all over 2 times our a value. So if I go to do that, I have x equals 8 over 2 plus or minus, and we need to simplify the square root of 72. I find that it's easy to take it to the side and simplify that real quick. So I'm going to use a factor tree to help me here. Now 72, that is the same thing as 3 times 24, because there's 24 hours in a day. 24 is 3 times 8, and 8 is 2 times 2 times 2. So then I take my pairs of factors and I take them outside of the radical. So I have a set of 3 that can come out and a set of 2's that can come out. So the square root of 72 is really 6 root 2. So this expression turns into x equals, and then I can divide both of these by 2. So 4 plus or minus 3 root 2. So those are the 2 real solutions. And they're really ugly, right? So it's not something that I would have been able to reach by factoring, which is why the quadratic formula is so nice. Now this middle example is going to be one in which the discriminant ends up being 0. So let's watch what happens. So again, we identify our a, b, and c. So my a here is 4. My b is negative 28. And my c is 49. So then I go to plug these in to b squared minus 4 times a times c. Okay, so my b again. That negative 28 goes here, the a into the second, and then the c into the third. So if I do 28 or negative 28 squared, that's 784 minus 4 times 4 is 16 times 49 is also 748, which again, when I subtract, gives me a discriminant of 0. So what that means is that this parabola is touching the x-axis at exactly 1 point. Now because my a value is positive, I know this parabola opens up. So that means that it's going to be a situation like this where the parabola comes down and touches it and then turns back away. So I might want to figure out what that x-intercept is. So I go back to my quadratic formula, which is now going to be a lot easier because this all reduces into a 0. So I have x equals negative b, so negative 28, plus or minus the square root of 0, which won't matter, all over 2 times a, which is 4. So when I go to simplify, these double negatives cancel out, leaving me with a positive 28. The square root of 0 is 0, so it doesn't matter if I add that 0 or subtract that 0, it's not going to do anything. So I'm just going to leave that 0 out. And then 2 times 4 is 8. And then I can reduce this fraction. 28 and 8 are both divisible by 4, and that would leave me with 7 halves. So this parabola goes down, touches 7 halves, and then goes back up. Now this last one is an example when your discriminant is less than 0. So when your discriminant's a negative value. Alright, so we identify a, b, and c. So we have a is 1, b is negative 3, and c is 4. So b squared minus 4ac. Okay, I plug in my negative 3, 1, and 4. Negative 3 squared is 9, minus 4 times 1 is 4, times 4 is 16. That gives me a negative 7. So because this value, which will go under a radical, is negative, I'm going to get a an imaginary number for my answer. So if I take it to the quadratic formula, I say x equals negative b, so negative negative 3, plus or minus the square root of negative 7, all over 2 times a. So when I go to simplify this, negative negative 3 is a positive 3, plus or minus. Now this negative under the radical, we take it out of the radical by turning it into the imaginary I. So this is I root 7. And then it's over 2 times 1, which is 2. And then we normally like to split this into the form x equals a plus or minus bi. So I'm going to split this fraction into 2 terms. So it's x equals 3 halves plus or minus the square root of 7 over 2i. So those are the 2 imaginary solutions, and you know they're imaginary because they have an I in them. So that is our discriminant and the 3 different forms that you'll see it in.